Hello class, this is a video tutorial on the factorizing the difference of two squares. So by this we mean if we have two squares, well, two squares would be something like this, and the difference, well, we have two squares, a squared and b squared, and the difference would be just a subtraction. Now the interesting thing about this factorization, it only ever applies to the difference of two squares, and it looks like the following. What happens is we take the square root of the first one. So what's the square root of a squared? Well, the square root of a squared is a, and then we add the square root of the second term, which is b squared. Square root of b squared is b, and we put that in one group, and we take the exact same group, except it's a minus. I'll do a visual proof of this in the near future. So using just this, we can use it to factorize a multitude of examples and a multitude of questions. So let's get straight into it. If we had x squared minus 4, so in this one we have two squares. X squared is a perfect square and 4 is a perfect square, so this will factorize into x plus 2 x minus 2. It's as easy as that. If we had b, if we had, take for example, x squared minus 36, that would factor into the square root of x is x, square root of 36 is plus 6, and then we repeat the same thing, but this time with just a minus, the difference of two perfect squares. Do a few more. Question C. What if we had 4x squared minus 25? This may look slightly different, but if you just take a look, 4 is still a perfect square. So we can actually do this. What's the square root of 4? Well, that's 2. The square root of x squared, that's x. And the square root of 25 is plus 5, like this, for one group. And we repeat the exact same thing in the other group. Let's do a few more examples here. Question D. If we had, say, 9y squared minus, we'll make this, say, 4z squared. Well, 9 is still a perfect square. That's a 3. Y is also a perfect square, so we can get a y. Whoops, nearly made a square there. 4 is a perfect square. 2 is the square root of 4. Z squared is a perfect square, so we put z. And I make the first one a plus, and the second one a minus. Let's just keep doing a few more here. E. Let's make it, and now here I'll really confuse you now with this one. Not really confuse you, really challenge you in this one. We'll go with 16y to the power of 4. Really think about that. And we'll make it minus, we'll make it 49b, okay, to the power of, we'll make it to the power of 9. Okay, so now this is a very challenging one here. So what I'm going to do is I'm going to break these all up. Okay, I'm going to break them all up. So we'll focus on 16 first. 16, the square root of 16 is actually 4. And the square root of 49 is actually 7. So these are going to be the numbers for these ones. So we have numbers. This one's going to be 3 and 4. For this one's going to be 4 and 7. But now with y to the power of 4, if we square root that, okay, it's a little tricky, but if you take a look, y to the power of 2 squared will give us y to the power of 4. So the square root of y to the 4th is actually y squared. And the same thing happens with b. b to the power of 9. Oops, sorry, this should be a 6. Let me just quickly change that question. Let's make that a 6. Let's make this a 6. So if we do a square root of b to the power of 6, we will actually get, take a look, since b to the power of 3 squared gives us 6, the square root of b to the power of 6 is actually b to the power of 3. Now that's a mind-bending one, but let's take a look. So it's going to be the square root of 16 is 4. The square root of y squared is square root of y to the 4th is y squared. So we put y squared like that. First one's going to be plus. The square root of 49 is 7. And the square root of b to the power of 6 is b cubed. So b cubed. And that's the first group, which we repeat for the second group. Okay, I'll just make this a little bit neater. Okay, so I'll just do this question down over here. Question E again is 16y to the 4 minus 49b to the power of 6. We actually get square root of 16 is 4. Square root of y to the 4 is y squared. Plus square root of 49 is 7. Square root of b to the power of 6 is b to the power of 3. So that's one group, and we're gonna repeat the exact same group on this and the next one, but instead of a plus, it's going to be a minus. Okay, so now let's move. So these are all with perfect squares. We can actually still factorize expressions of this nature, even if it's not a square. So let's take a look. This is set 1. Let's take a look at question 2a. In this time, we're only going to have x minus 3. It may not look like it, but we can still factorize these. It's actually going to be the square root of x plus the square root of 3 times the square root of x minus the square root of 3. So even if it's not a perfect square, we can still factorize it. We just pretend that they are squares and we square root them regardless. Okay, so let's now take a look. Question B. We have, let's take a look at 5x squared, okay, minus, we'll make it 4y squared. So one of these is a perfect square. Take a look. This one here is a perfect square, but this one is not. But what is the square root of 5? Well, it's actually going to be a decimal value, but instead we'll just keep it as a surd like that. And this is going to be the coefficient of x squared, which is the square root of x squared is x. And if you're wondering how this came about, because take a look, because remember how we said we want the square root of a. So in this question, we want the square root of 5x squared. So if we have 5x squared square root, this actually means the square root of 5 times the square root of x squared. So this cannot be simplified, but this one can. Hence why we have square root 5x. Okay, square root of 5x. Think of it as something like this. 5x, but instead of 5, it's the square root of 5x. It's a different number, but that square root of 5 is a coefficient. Okay, so then we're going to take plus the square root of this value, which is 2y, and that's our first group. We repeat the exact same group but with a minus, so it's going to be the square root of 5x minus 2y. Okay, so I know that second set was very challenging, but the main one I need you I'd like for you to remember is this here in the beginning.